This is lesson 32 of the Quantum Mechanics, a mini lecture series. So having talked about the general form of what a wave looks like, okay, in Schrodinger's mind, thought I'd do a slight deviation once again, just to get some context into what was happening with experiments at the time as well, just to make sure that I cover the experiments, the key experiments. So one of the great mysteries, one of the great remaining mysteries, I should say, till this day of quantum mechanics, having spoken about waves and particles, okay, the representation of light as being sometimes as a particle and sometimes as a wave, is the two-slit experiment. I'll begin by outlining a very simple intuitive experiment involving golf balls. Okay, two slits and a detecting screen. Suppose I have a golf ball launcher, golf ball machine here, golf balls, and I've got two slits. Okay, slits are like gaps in, let's say, a metal, and I've got like a detection screen. Let's call that S1 for slit 1, S2 for slit 2, okay? So if I was to fire these golf balls, I would find that most, from intuition, most would be found behind each, opposite each slit, right? So I'll have a lump here, opposite S1, slit 1, and a lump here, opposite slit 2. Some might make it between, right? That's from intuition, because we've got gaps, one here and one here. So a gap at slit 1, a gap at slit 2, and you'll find there's going to be bumps corresponding to where the golf balls flew through each slit. Now, if we close one slit or the other slit, suppose we do the same experiment, suppose we close slit 1, we'll find something like this from intuition. Okay, they'll build up behind slit 2. Okay, nothing much happening behind slit 1 because it's blocked. Same thing for slit 2. If I was to close off slit 2, keep slit 1 open, I'll find a lump behind slit 1. This is from intuition, from using everyday objects like golf balls. That's called the classical viewpoint, if you wish. Let's use light instead of golf balls. Let's have a light source here. Let's do the same thing with light. Okay, let's close slit 2, let's say. We'll let in light through slit 1. What would we see? What would we see? We'd see also like a bump behind slit 1. Now, here's where the funny bit comes in. Let's use electrons. Now, electrons, we can think of them as like golf balls, right? From our intuition, from the way we visualize electrons as like these little point-like particles. Let's send in electrons one at a time. Okay, we have an electron gun here, firing electrons, passing them through one at a time, and they'll strike a fluorescent screen, okay? A detector, in other words, okay? And fluorescent screen, it signals a flash of light whenever a position of an electron can be measured. Whenever an electron strikes the screen, it indicates that there'll be a bright light spot, right? If let's say we block the first slit, we'll sort of find like a bump once again behind the second slit. Nothing here, no mysteries here still. Okay, similarly, if you close slit 2, keep slit 1 open, you'll find the same thing, a bump. If, however, you open both slits, you'll see something like this. A maximum peak followed by little peaks getting progressively smaller. This is called an interference pattern. This is what you observe with light waves. Okay, if you were to shoot light waves through two slits, you'll see something like this, interference pattern, where the peaks and valleys, where if the waves, okay, so from each slit, suppose you've got a wave like this from slit 1 and a wave like this from slit 2, if their peaks and troughs match up, okay, if there's a correspondence, if the waves are in line, if they're in sync, the peaks add up and you'll get constructive interference. You get a build-up, a build-up of peaks, right? If, however, the waves are out of sync slightly, you'll get destructive interference. You'll get a flat line. In other words, no light. Whereas here you'll get a bright light band. So you get a series of dark and bright spots called an interference pattern, like this, where the peaks correspond to bright spots, the troughs correspond to dark bands, dark spots. So you've got here particles arriving in lumps, just like golf balls, but a pattern is formed, which is characteristic of that of a wave, okay? And waves pass through both slits. That's how they work, simultaneously. And you can actually predict this using the de Broglie relation, lambda is equal to h over p, predict the wavelength of the electrons. An absolute mystery why this is happening.